To create designs for equipment and spaces that can be used safely and effectively by the operators that will use them, you need to understand who these users are, what it is that they need and want to do, and how they will do this with your product in their working environment. In plain terms, that is the core of user-centered design, and the goal is efficient, effective, safe, and satisfactory interactions. There are many ways to get the user involved in the process, and you can and should be creative based on your situation and resources. We provide some example methods and guidance to help you in the process. Input from the users and other stakeholders should be gathered before you start the actual design, iteratively during the design phase, and also to evaluate the final design. Let's start with the pre-design phase. User-centered design does not need to be extensive or expensive. Even a few simple UCD activities early in development will significantly reduce the overall cost of developing an acceptable system. First, determine what kind of product it is that you are designing and what the business goals are for this product. This is the stage where you should identify who all the stakeholders are, both within your organization and outside, and assemble a basic understanding of their vision, requirements, and goals for development. Performance feedback, problems, and feature requests from existing systems should also be analyzed. This will help to identify the true compelling need for your product, the expectations, and to align business goals with UCD goals. Even if you are not able to organize a full-fledged stakeholder meeting, be sure to collect the information required in one way or another. Some topics to cover in a stakeholder analysis are listed here. Start by seeing how many of these questions you can confidently answer, and then think about ways to get answers or confirm those that you could not answer or were not sure of. In the framework section on pre-design, we provide a product report template that can be downloaded to help get you started on describing the product and capturing that information, as well as other links and resources to give more guidance. After the stakeholder analysis, you should ask yourself what kind of access you have to the crew, the users of the systems, and usability data, and how you can best use these opportunities to get more information and feed these into the design process. Consider existing customers, knowledgeable coworkers and their networks, or access to ships for maintenance or repair calls for your existing systems. The goal is to get in contact with users as early as possible. Therefore, straightforward methods such as observation and interviews are strongly suggested to get started, and these methods are explained more in the following slides. One straightforward technique is to benchmark relevant existing designs using a set of usability heuristics. This will both increase your awareness of what exists, as well as get you thinking about these designs in terms of the users. Here is one example list of heuristics for user interface design from Nielsen. I'm not going to read these here, but they can be reviewed later, and a link is provided to a slide share with examples illustrating each. Here's an example list of heuristics for workspace design. I'm not going to read these here, but they can be reviewed later, and a link is provided to bad design examples where these are expanded on with pictures. You need to identify in detail who will use the system, how it will be used, and the important contextual factors that impact how the system will be used. If this information is not already easily available, field research may be needed to obtain more details. There is often not just one answer to these questions of users and tasks. Are you designing for all situations and all possible users from a 1-meter female to a 2-meter male? Or is it a specific application or user group? Or is it multiple groups with different requirements? Now you know what contextual information you need, and can use the suggested methods or other methods to go out and get it. A contextual analysis report template can also be downloaded from the pre-design section of the framework to help you identify and describe the most important contextual factors. Some case study examples applying these methods in the maritime context are provided as well. Observation is one of the 2 suggested methods to start getting into contact with users and learning their tasks and context of use. Conducting interviews is the other suggested method, and both methods can be combined and tailored or adapted as needed for your situation. You then need to translate what you know about the users and context into design-friendly language and measurable targets. The trick is to integrate this information into your team's relevant product requirement specifications and activities. Some methods, such as the use of personas or scenarios of use, can help to capture these ideas in a way that is easy for the design team to use. Your goals at the end of the process is to truly understand the range of primary and secondary users, the priority requirements that support these users, measurable goals for your design that can be tested to see if you succeeded, and that the users have reviewed your requirements and accepted them. Now we discuss user-centered design during the iterative design process. The objective of the design phase is to create and develop a design that is based on the requirement specification and that supports the users with their task at hand. Early designs will be simple and sketchy. These will mature into one final design through an iterative process of evaluation and redesign. Many designers hesitate to show a design or concept until it is relatively finished and final looking, but this is not good practice. Users might be reluctant to suggest bigger changes to a finished looking product. You have to use your opportunities to show the concepts to real users as early as possible. Getting feedback on these conceptual designs allows for rapid changes in response to user feedback, and at minimal costs. Do not hesitate to work with progressively more detailed prototypes, as you move from simple paper or cardboard mockups to more interactive designs with increased confidence based on the user input at each iteration. And now we discuss evaluating your design. There are two main reasons to conduct usability evaluations. The first reason is to improve the product as part of the development process. This is called formative testing. The second reason is to find out whether people can use the product successfully. This is called summative testing and is conducted at the end of the design process. You can learn more about conducting usability evaluations via the resources provided, and also see a case study based on ECDIS. Never stop learning and improving. Some best practices include making sure that you document your UCD activities and results in a way that your company can take advantage of them, for example for other projects or at a later point in time. Monitor any problems that occur in the installation, training, and user support after release. Also make sure that there are systems in place to obtain continued feedback for the next design iteration. These can be things such as service calls or logs from visits or annual surveys. You also have to continue testing and measurement after the product has been released to gain an increasingly truer picture of how the product is performing in relationship to the reusability goals you set for it. Data from continuous testing can give you an advance warning where user support will be most needed, indicate what are good sales points for the product, prioritize bug fixes and improvements, use as benchmarks for future releases, and also feed into the requirement specifications for the next version. This table shows some other methods you can consider as well. The more you can integrate this kind of knowledge and thinking throughout the design process, starting as early as possible, the greater your chances of success and not having to make costly changes later in the design cycle. Once a system is in development, correcting a problem can cost an estimated 10 times more than fixing it during design. Once a system is being used, it can cost 100 times more.